Hello everyone. Here we are going to see Unit 11 processing n jobs on three machines. So structure of this unit is objective, introduction, condition for converting three machine into two machine, procedure for determining optimal sequence for n jobs on three machines, then solved examples, sum up and some keywords and some terminal questions for you. First thing is objectives. So in this unit, students are able to understand how to solve, maximize the efficiency and free flow of the production at a minimum cost and minimum time. So introduction of this unit. In this section, we discuss on extension of Johnson's procedure for scheduling n jobs on three machines A, B and C in the order ABC. This list of jobs with their processing times on three machines A, B and C is given below in the table, and suppose the machines, let machines A, B, C, B, the three machines, let the order of operations be A, B, C, and this problem can be converted into two machine if any of the conditions is satisfied. First thing is the minimum processing time on machine A is at least as greatest the maximum processing time on machine B. That is minimum T1 greater than or equal to maximum T2. The second condition is the minimum processing time on machine C is at least as greatest the maximum processing time on machine B, that is minimum T3 is greater than or equal to maximum T2. Maximum T2. Okay. In other words, it is what's there in the condition means minimum duration of the first machine is greater than or equal to maximum duration of the second machine. That is a minimum of A greater than or equal to maximum of B. Okay, and in the second condition, minimum duration of third machine is greater than or equal to maximum duration of the second machine. That is minimum of C greater than or equal to maximum of B. That is what there in the condition. If the method fails if none of these conditions is satisfied. None of these conditions is satisfied. Then condition for converting three machine into two machine problem. In the three machine case problems falling under this category can be converted by the method developed by Johnson. Following are the two conditions of this approach. The smallest processing time on machine A is greater than or equal to the greatest processing time on machine B. That is minimum of A greater than or equal to maximum of B. Minimum duration of the first machine A greater than or equal to maximum duration of the second machine B. And the second condition, the smallest processing time on machine C is greater than or equal to the greatest processing time on machine B. That is minimum duration of the third machine C greater than or equal to maximum duration of the second machine B. That is minimum of C greater than or equal to maximum of B. Or else maximum of B less than or equal to minimum of C. Both are right. Okay. Then procedure for determining the optimal sequence for M jobs on 3 machines. If either or both the above condition holds good, then good means holds satisfied conditions. Either both conditions are satisfied or any one of that conditions are satisfied means then the algorithm can be summarized in the following steps. Step 1. We have to examine first the processing time of the given jobs on all 3 machines, and if either one or both the above condition hold, then go to step 2. Otherwise, the algorithm fails. What's there in the step 2 means introduce two fictitious machines, say G and H, with corresponding processing time given by G equal to A plus B. That is, G is replaced by, we have to add the first two machines A and B. Whereas in H, we have to add the second machine and the third machine, that is B and C. The sum of the processing times of machines B and C. That is Tg equal to T1 plus T2. That is the processing time on machine G is calculated by the sum of the processing time on machine A and B. Whereas TH is replaced by T2 plus T3, that is the processing time on machine H is calculated by the sum of the processing time on machine B and C. Then go to the step 3, determine the optimal sequence for n jobs and 2 machines. Equivalent sequencing problem with the prescribed order GH in the same way as discussed earlier. That is, we can obtain. Thus, we have n jobs into 2 machines. That n job problem can be converted into 2 machine problem. After that, we have to find an optimal sequence for this problem. That is what there in the step 3. Then worked problems. First problem, find out the sequence that minimizes the total time required in performing the following jobs on 3 machines in order A, B, C. Processing times in hours are given in the following table. That is, first row denotes the job values, that is 1 2 3 4 5, and the first column denotes the machines, machine A, machine B and machine C. Rest of the column and rows denotes the processing time values for machine A, B, C in the corresponding job order. Okay, so see here, from the data given below, data in the problem, we see that minimum TA is 6, minimum of the machine A. Minimum job value for machine A is 6 and minimum job value for machine C is 4 and maximum job value for machine B is 6. So, the condition minimum A greater than or equal to maximum B. Minimum of A is 6 and maximum of B is also 6. It is greater than or equal to. Therefore, that condition is satisfied for all J. The given problem can be converted into a problem of 5 jobs and 2 machines. The processing times on two dummy machines G and H can be determined by the following relationships, that is TG is equal to TA plus 2B, TB. Here we are going to sum or add the first two machine values, that is machine A plus machine B, and the second dummy machine H is calculated by adding the second machine and the third machine, that is machine B and machine C. The processing time for the new problem can be given below. Yes, first row denotes the job values 1, 2, 3, 4, and 5. And the second row denotes the first dummy machine, machine G. So here we are going to add the first addition of the first two machines A plus B. So 8 plus 5 is 13. 10 plus 6 is 16, 6 plus 2 8, 7 plus 3 9, 10, 11 plus 4 15. And in machine H, we have to add the second machine and the third machine, machine B plus machine C. That is 5 plus 4 9, 6 plus 9 15, 2 plus 8 10, 3 plus 6 9, 4 plus 5 9. Then we have to find the optimal sequence for the given two machine problem, the converted two machine problem. When the procedure described for n jobs on two machines is applied to this problem, then the optimal sequence obtained is given by 3, 2, 5, 1, 4. Next, you are going to find the minimum total elapsed time. For that, first you are going to frame a table first. In that table, the first column denotes the optimal sequence column. In that column, we have to write the job value as in the order in the optimal sequence, that is 3, 2, 5, 1, 4. And next thing is machine A, time in, time out. Machine B, time in, time out. Machine C, time in, time out. Okay, so for machine A, for the first machine, the first time in value is always be 0. Always be 0. And the second time out, the first time out value for machine A is calculated by, we have to add the time in value 0 plus the value, the processing time value for machine A in job 3. It is there in the problem. For job 3, the processing time value in machine A for job 3, the processing time value is 6. So we have to add in value plus 6. 0 plus 6 is 6. Now we have to write this out value here. So 6 for in value 6, for out 6 plus, add 6 plus the job processing time for job 2 in machine A. It is 10. See here, it is for second job, the processing job value, the processing time for machine A is 10. So 6 plus 10, 16. 16. Likewise, you have to find out all these values. Then moving on to the machine B. In machine B, the time in value is the time out value of machine A, that is 6. For machine B, we have to add in value 6 plus the third processing time for job 3 in machine B. Job 3 in machine B. Job 3 in machine B is 2. So 6 plus 2, 8. 8. So now we are going to compare 8 and 16. 8 and 16. Maximum of 8 and 16. It is 16. So write it here, and out value 16 plus what is the processing time for job 2 in machine B? It is 6. So 16 plus 6, 22. Then we have to compare 22 and 27. 22 and 27. Okay. So maximum of 22 and 27 is 27. 27. So here 27 plus the job processing time for job 5 in machine B is 4. So 27 plus 4 is 31. Then maximum of 31 and 35 is 35. So 35. Write it here, and out value is calculated by 35 plus processing time for first job in machine B is 5. So 35 plus 5 is 40. 40. Now we have to compare these two things, 40 and 42. Maximum of 40 and 42 is 42. So write it here, and here we have to add 42 plus the job processing time for job 4 in machine B is 3. So 42 plus 3 is 45. Likewise, you have to find time in and out values for machine C. Machine C. Therefore, the minimum total elapsed time is 51 hours. 51 hours. So, it is the minimum total elapsed time is the last machine's last out value. Last machine is 6 and its last out value is 51. That is what the minimum total elapsed time. Minimum total elapsed time. Then ideal time for machine A, B and C. Ideal time for machine A is minimum total elapsed time 51 minus of final out value of machine A. It is 42. Final out value of machine A, 42. So 51 minus 42. It is 9 hours. 9 hours. Then ideal time for machine B. Ideal time for machine B. It is calculated by, for that first we are going to check whether the difference is there between these two numbers, 16 and 6, 27 and 22, 35 and 31, 42 and 40. Yes, of course, difference is there. So we have to find it by this thing. We have to write the first in value 6 plus the difference between 16 and 8, and the difference between 27 and 22, and the difference between 35 and 31, and the difference between 42 and 40. And last thing is the difference between the total elapsed time minus final out value of machine B, that is 51 and 45. 51 and 45. 51 and 45. It is 31 hours. 31 hours. And ideal time for machine C. Ideal time for machine C. It is, for that also we have to check whether the difference is there or not. 22 and 16, 31 and 31, 40 and 46, 45 and 44. Yes, of course, difference is there. So we have to write the first in value 8 plus the difference between 22 and 16, and the difference between 31 and 31 is 0, so no need to write, and the difference between 40 and 36, and the difference between 45 and 44. So it is 19 hours. 19 hours. 19 hours. Okay. Yes, moving on to the next problem. There are 5 jobs, namely 1, 2, 3, 4, and 5, each of which must go through machines A, B, and C in the order ABC. Processing time in hours are given below in the table. So using this, we have to find the sequence that minimum the total elapsed time required to complete the jobs. Okay, so here given is a 3 machine problem. We have to check whether that the 2 conditions are satisfied or not. So minimum of the first machine, minimum value of the first machine is 5. Then maximum value of the second machine is 5. Then minimum value of the third machine is 3. So minimum of A is greater than or equal to maximum of B. So minimum of A is 5 and the maximum of B is 5. So that condition is satisfied. Therefore, the given problem can be converted into 5 jobs and 2 missions. 5 jobs and 2 missions. So for that, first column denotes the job values, that is 1, 2, 3, 4, and 5, and in the second column denotes G. G is calculated by adding the first machine and the second machine jobs processing time value. So 5 plus 2 7, 7 plus 1 8, 6 plus 4 10, 9 plus 5 14, and 5 plus 3 8. And the last column, third column H, is calculated by adding the second machine and the third machine, that is B and C, B plus C. That is 2 plus 3 5, 1 plus 7 8, 4 plus 5 9, 5 plus 6 11, and 3 plus 7 10. After that, you are going to find the optimal sequence. It will be like 2 5 4 3 1. Then total elapsed time will be, for that we are going to frame a table first. So first column denotes the job column. It is, we have in that column we have to write the optimal sequence order, that is 2 5 4 3 1, and machine A in out, machine B in out, machine C in out. Okay, so for the first machine, first in value is always the 0. In the out place, we have to add the in value 0 plus what is the processing time for second job in machine A. Second job in machine A, it is 7. So 0 plus 7 is 7. 0 plus 7 is 7. Now we are going to write 7 here, and out value is calculated by adding in value 7 plus the processing time for the fifth job in machine A is 5. So 7 plus 5, 12. Okay, likewise, we have to find all these things for machine B in and out value, for machine C in and out value, in and out value. Okay, then total elapsed time, minimum total elapsed time. It is the last machine's last out value. Last machine is machine C. Its last out value is 40. So 40 hours. Then ideal time for machine A. Ideal time for machine A. It is the difference between the minimum total elapsed time and machine A's lost out value. So 40 minus 32, it is 8 hours. 40 minus 32, it is 8 hours. Then ideal time for machine B, for that we have to find whether the difference is there or not. 15 and 8 difference is there, 21 and 15 difference is there, 27 and 26 difference is there, 32 and 31 difference is also there. For that, first we have to write the first in value 7 plus the difference between 12 and 8, the difference between 21 and 15, the difference between 27 and 26, the difference between 32 and 31. And the difference between the total elapsed time 40 minus final out value for machine B 34. 34. It is 25 hours. 25 hours. Okay. Then machine C. Machine C. Ideal time for machine C. For that also we have to check whether the difference is there or not. 15, 15, 26, 22, 32, 32, 37, 37. In this place 26 and 22 has a difference. Rest of the place will have not a difference. So for that, first we have to write the first in value 8 plus the difference between 15 and 15 is 0. No need to write. The difference between 26 and 22, and the difference between 32 and 32 is 0, and the difference between 37 and 37 is also be 0. So no need to write. So first in value 8 plus the difference between 26 and 22. It is 12 hours. It is 12 hours. Okay. So moving on to the next problem. A company has to process 5 items on 3 machines A, B and C. Processing times are given in the following table. We have to find the sequence that minimizes total elapsed time. Total elapsed time. Here minimum of A is 3, maximum of B is 6 and minimum of C is 6. Therefore, the condition maximum B less than or equal to minimum C. Maximum B less than or equal to minimum C. Maximum of B is 6 is less than or equal to minimum of C is also 6. Therefore, this condition is satisfied. Now, we consider two fictitious machines G and H with corresponding processing times. G equal to addition of first two machines and H equal to addition of second two machines B and C, where H, G are the processing times for the ith job on machines G and machine H, respectively. The processing times for new problem are given below. So first column denotes the job values 1, 2, 3, 4, 5. Second column denotes the dummy machine G that is added by the first machine and the second machine, and the third column denotes the dummy machine H. Here we are going to add the second machine and the third machine. So following Johnson's algorithm, the optimal sequence can be obtained as 1 4 5 3 2. 1 4 5 3 2. Okay, after that we are going to find in out table for values for all the machines. In that table, first column denotes the optimal sequence column, that is 1 4 5 3 2, and for machine A, first in value is always be 0 and out value is calculated by adding in value 0 plus processing time for job 1 in machine A. It is 4, so 0 plus 4 is 4. Likewise, we have to find all these things. Then total elapsed time. Total elapsed time is lost machine's lost out value. Lost machine is machine C and lost out value is 49. Its lost out value is 49. So minimum total elapsed time is 49. Ideal time for machine A is minimum total elapsed time 49 minus of final out value of machine A. It is 30. So 49 minus 30 is 19 hours. Then ideal time for machine B is first in value 4 plus the difference between 10 and 8 plus the difference between 13 and 12 plus the difference between 21 and 19 plus the difference between 30 and 24. It is 29 hours. Then the difference between the total elapsed time 49 minus final out value of machine B, it is 35. Okay, then ideal time for machine C is first in value 8 plus the difference between 14 and 14 is 0 plus the difference between 22 and 22 plus the difference between 29 and 29 plus the difference between 40 and 40. It is 8 hours. 8 hours. So one more question is there. Example number 4. It is some masala company, that is MDH, has to process 5 items on 3 machines A, B, C. Processing time are given in the following table. We have to find the sequence that minimizes the total elapsed time. That they have given 3 machine problem. First of all, we are going to check whether the condition is satisfied or not. For that, minimum of A is 3, maximum of B is 6 and minimum of C is 6. Since the condition maximum B less than or equal to minimum C is satisfied, therefore the problem can be solved by the above procedure. Though the processing time for the new problem are given below. First column denotes the job values 1, 2, 3, 4, 5 and the second column denotes the dummy machine G. In that we have to add the processing time values for the first machine and the second machine, and third column denotes the dummy machine H. And here we are going to add the second machine and the third machine's processing time value. Then we are going to find the optimal sequence. It is 1 4 5 3. After that we are going to frame a table. In that table, we have to calculate in and out values for all the machines. Then total elapsed time, it is lost machines lost out value, that is 49, and ideal time for machine A, it is total elapsed time minus final out value of machine A. Total elapsed time is 49 and the final out value of machine A is 30. So the difference between 49 and 30 is 19 hours. Then ideal time for machine B is first in value 4 plus the difference between 10 and 8, the difference between 13 and 12, plus the difference between 21 and 19, plus the difference between 30 and 24, and the difference between total elapsed time 49 minus final out value of machine B. So 49 minus 35, it is 29 hours. Okay, then ideal time for machine C is first in value 8 plus the difference between 14 and 14, the difference between 22 and 22, the difference between 29 and 29, the difference between 40 and 40. It is 8 hours. 8 hours. So, what we have studied in this unit is we have learned about the optimal sequence for n jobs on 3 machine problems, and the characteristics of the optimal sequence for n jobs on 3 machines, and make solve the problem the optimal sequence for m jobs on 3 machines. Okay, some keywords have been given for you. Ideal time, it is the time on machine is the time the machine remains ideal during the total elapsed time. Then total elapsed time, it is the time between the starting the first job and completing the last job. And some terminal questions have been given for you. You have to make use of it. Okay, thank you. We'll see in the next unit.